mathematics. How much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
All right, calculus students, good morning. It is Tuesday morning, May the 12th, and you've been working on integration by substitution. I haven't received any questions from you, so either that means you are getting it or you haven't done it yet. If you're getting it, fantastic. If you haven't done it yet, work on them. Try to get as many of those questions done as possible. If you have questions, ask. They do get difficult, and I recognize that, and I expect you to have questions. So please ask questions if you have them. Today we're going to move into integration by parts. And integration by parts is an undoing of the product rule. All right, so you remember our product rule. The product rule says if we're taking the derivative, d dx, of a product, f of x times g of x, then the derivative is f of x times g prime of x plus f prime of x, g of x. Right? So that's our product rule. Now if we want to reverse that, we want to take the integral of this and it has to equal the original. So here it is, the integral of our f g prime of x plus f prime of g of x equals our f of x times g of x. Okay, so it's exact opposite. The integral of this piece has to equal this piece. All right, with integration, if we have the integration of a sum, we can break that up into two pieces. We have the integral of the first piece plus the integral of the second piece, still equaling our f of x, g of x. And then just to make it into our rule that we're going to use is we're going to make it the integral of this first piece, f of x times g prime of x. And then we're going to subtract this integral from both sides. Okay, so we got our f of x, g of x minus the f prime of x, g of x. And that becomes our rule. And what that means is that when we are finding the integral of a product, f times g of x, we're actually going to be integrating twice. We're going to integrate, and we're going to set it up like this, which means we're going to integrate again here. All right? And the best way to show you how to work this is to use an example. This formula is on your formula sheet. So you won't have to memorize it in any way. But I've got an example set up on the other board, and we'll show you how to use this a little bit, and I hope that it will make sense, and we'll go from there. All right, so here's our first example. We've got a product. We've got x times e to the x. We want to integrate this. Now, the first thing you want to do is you want to recognize a couple things. First, just integrating it normally, we're using the reverse of the power rule, will not work. There's no exponent that we can increase by 1 and divide by, that's just not going to work. We look at trying substitution. For substitution, we want to pick an inside function and then take the derivative. Well, the only inside function I have is this exponent x, right? And if I take the derivative of x, I just get d of x, or dx, right? And here's the dx. Okay, so that I can substitute out. I could say that, and that would substitute with something else, but then it still leaves this x here. And so that won't work. I can't substitute to get rid of the x. I can't put in u for the x's. All right, so that means we have to try something else, and this is by parts. Now, sometimes the by parts rule is written this way, and it's an easier way to write it. And so I'll just write it again the way it is in your formula sheet. It's actually formula number 1 on your formula sheet, and it says this. It says the integral of u dv equals u times v minus the integral of v du. Okay, so if we think back to the other page, it was f times g prime of x, right, equaled f of x times g of x minus the integral of g prime of x, f of x. All right, so it's the same thing, it's just using u's and v's, just a little simpler. So what this means, what we have to do is we have to, in our x e to the x, we have to identify which one of those pieces is going to be u and which one of those pieces is going to be dv. All right, so that's what we want to do. We want to go u and dv. We want to select two things. And now what you have to recognize is that once we have u and dv, we also need du and we're going to need v. So we're going to need, from what we select here, we are then going to find the derivative of u and the integral of dv. Right? And so we're going to get these four things, which are the four things we have here, right? We have u and dv, uv, v, and du. We have these four pieces, we need to identify them. So starting here, identifying u and dv. All right, and here it is just literally, it is a guess. You pick one to be u and the other one to be dv. And so in this case, we're going to choose u to be x, and we're going to choose dv to be e to the x. All right, and if we do that, the derivative of x is dx, and the derivative of, or the integral of e to the x is e to the x. All right. Okay, so now we want to use this formula. So what we had here is we had this, and I'll rewrite it again. We had the integral of x e to the x dx. That's going to become u times v. So u was x. V is e to the x minus the integral of v, which is e to the x, times du, which is d to the x. Okay, so we are still making substitutions, so it's kind of like still a substitution rule, but it's doing it by parts. Okay, so we've identified two parts, we've found the other parts, we make the substitution. Now, the point of this is that this integral here should be an easier integral than the original one. And it is, right? The integral of e to the x is easier than the integral of x times e to the x. Right? So now we're going to finish this up by taking the integral of e to the x, and so this will simply become x times e to the x minus, and we know that this integral is e to the x. And there is our answer. We could factor out the e to the x and get, x minus 1 and get that. All right. And then, of course, because we don't have an upper and lower bound, we are going to be adding a c to the end, as we will in all of our indefinite integrals. All right. So that becomes the answer, and if you want to take the derivative of this using the product rule, you will see that you will simplify to this answer here. You can try that, challenge you to try that, and see what happens. All right, let's do a few more examples just to sort of solidify this. But I do want to point out before we go on here, what would have happened if we had made the wrong choice here? Okay, so if we'd have made, so we're just going to get a different marker. If we'd have made a different choice here for our u and our dv, what would have happened? So over here, let's say, again, we're going to go u and dv, v, make it look like a v, and du and v. And if we'd have made a different choice, so here we chose x and e to the x, what if we'd have gone e to the x and x? Okay. What's the derivative of e to the x? Well, we know that that is e to the x dx. And what's the integral of x? Well, the integral of x is x squared over 2. Right? Okay, now look what happens when we put it into into here. And I'm just going to look at this back piece here. Remember that this piece here has to be simpler. And this back piece is v du. What does v du become here? It becomes x squared over 2 times e to the x dx. And you'll notice that this is a much more complex integral than this. The whole point is you want to get simpler, not harder. And so if you do this, it works. You can do this, but you haven't made it easier, right? You've made it harder. Okay, instead of having x dx, you now have x squared e to the x. Okay, and so you've made it more difficult rather than easy. And so this is the right choice here, not this. You would not want to do this, as it makes it more difficult, not easier. Let's go do another example, and we'll see if we can solidify this and make it make sense. So here's our second example. We've got the integral of x times cos 3x dx. Now, again, we want to try substitution first. So over here in this box, I've tried substitution. If I let u equal 3x, because 3x is the inside function, right? Cosine of 3x. So 3x is the inside function. If I take the derivative of 3x, so du equals 3 dx, divide both sides by 3, and I get my du over 3 equals dx. All right, over here though, I can let this equal to u, but here I have this x, and I don't have an x here, right? I just have a dx, and here's the dx. This x would not get substituted out, and so we cannot use the substitution rule or the integration by substitution in order to solve this integration, so that will not work. All right, so that leaves us with integration by parts. And so again, now we have two parts, right? We have this part, the x, and we have the cos 3x. And we want to let one of the pieces be u and the other piece be dv. Again, you're just going to make a choice. If you get it wrong, you'll just have to do more work, because again, if you get it wrong, you'll see the integral become more complex rather than simpler. All right, so here we are going to let u equal to x, and that means that dv is cos 3x dx. Okay, there's our two parts, u and dv. Here now we take the derivative of x, which is dx, and we take the integral of cos 3x dx. And the integral of cos 3x dx is going to equal, again, to do this, you could use a substitution rule now, because now a substitution rule will work for this. And what you'll find is you will get 1/3 sine 3x. All right, so you can just remember this, that if you have a 3 here, it's going to become a 1/3. Or again, to take the integral of this, you typically, what we had been doing previously would be using substitution rule. We would let u equal 3x. That means that du is just 3 dx, and then you would divide both sides by 3, giving you this 1/3 factor. All right, so now we're going to use our rule, and again, I'll write down the rule here. It's the, if we're taking the integral of u dv, the answer becomes u times v minus the integral of v du. So let's do this. We have the integral of x times cos 3x dx equals u, which is x, v, which is 1/3 sine 3x, minus the integral of v, which is 1/3 sine 3x, times du, which is dx. All right. This 1/3 can be pulled out front of the integral. We don't want to necessarily worry about it, so I'm going to pull it out front. And that is one of our integration properties, that constants can be pulled out front. All right, now we want to work on this. And again, what you'll see here now is this integral is easier than the original one we had. So we're just going to leave this the same. I'm just going to rearrange this a little bit. I'm going to take this 1/3 and move it out front. 1/3 x times the sine of 3x minus 1/3. And now we're going to integrate sine 3x again. Use the substitution rule to take that integral, and what you will find is that it becomes negative 1/3. Sorry. Negative 1/3 cos 3x. Right? And when we simplify this then, you just get rid of those brackets. This final answer will be 1/3 x sine 3x. Here I have a negative 1/3 times a negative 1/3. It's going to become a positive 1/9. And then cosine 3x. And then, of course, to finish it off, because this is an indefinite integral at the end, we are going to add plus c because there could be a constant that we are unaware of. All right, so there you go. That is how you do integration by parts. That's 2 examples. There are examples, or there are questions you could get where, if you'll notice here that this started with an x and then the x disappeared here. Okay? If this started with an x squared, this would become an x, and then you would have to do integration by parts again on this piece, and so on. If this was an x cubed, this would become an x squared. You do integration by parts, it would become an x. You do an integration by parts until it disappears. But every step, the integration gets easier and easier to do. And there are some shortcuts when you have larger exponents on this x. There are some shortcuts that you can learn. Actually, in your textbook, there's a table. It's called tabular integration. You can look at that. But because it's the same thing over and over and over again, I will tend in this course to not give you those questions, because if you can do it once, the assumption is that you can do it multiple times. And so we'll leave it at that. And your assignment today will be from a handout from the other textbook that we're using. And do those, and you'll ask any questions that you have. And as we work towards the end of taking integrals, we want to move into some applications of integrals in the next week or so. And so you want to get these questions done, ask any questions so we can go over them, and we'll go from there. Have a great day, and we'll see you in a couple days.